Hello, today we will discuss the proportions. In this chapter we have two types of proportions, direct and inverse proportions. Let's understand first what is direct proportion. Consider an example in this slide in which we have a data about the penalty on the books when not given back in time. So the fine that is charged for each day is 15 cents for a book that is borrowed from the library. In the table we see that on each day there is an increase of the fine of 15 cents. So we have 10 days data and the fine starting from day 1, which is 15, and 30 on day 2, 45 on day 3, 60 on day 4, and subsequently it reaches 150 on the 10th day. So there are different observations that can be made from this data. So if we investigate, we see that each time when the number of days increases, the fine increases, and this fine increases with a certain proportionality. For example, if we have a fine on a particular day, then the next day the fine becomes double. And on the third day it becomes the triple. So by this way we can see that there is a proportionality in the increase of the fine. Similarly, when the number of days decrease from the point of view of the table, from the right hand side to the left hand side, we see that the fine also decreases, and it has the same kind of proportionality. Now this fine becomes half for the first or the one day, and for the next day it decreases to 1/3. So this kind of relationship, that if one variable increases, resulting in the increase of the other variable, like in this case we have the number of days and the quantity of the fine. Similarly, when we see that if we decrease the days, it also decreases the fine. So it gives us the sense of a direct proportionality. That is, if one variable increases, the second also increases, such that we have increase in the fine as the number of days increases. And similarly, when the number of days decreases, the fine also decreases. So let's do something more about that table. So this is the same table with another row added. We can see on the third row that if we divide the price or the fine by the days, the subsequent day or relative day, we get the same number. So we divide the two rows, each number in each row with respective number of days. Like we have 15 as defined on the first day, we divide 15 by 1, 30 defined on the second day and divide with the number of days 2, and so on. We get the same number of rate, that is 15, each time we define on that particular day. So this is what we can call as the rate. So from that observation, we can mathematically write the direct proportionality as the ratios of two variables. Like we have x1, y1 and x2 and y2 as two variables. For example, in the case of fine and the number of days, we can set one variable as x and the other one as y, and we can have different values. For example, on the very first day we can have the value x1 and its fine y1, and similarly on the second day we can have the day as x2 and the fine y2. So there, from the table we already saw that we define in the third row a rate which is equal for each column, and from that we can set there is a proportionality which gives us a constant ratio. That means we can have the ratio or the rate equal for two different values of two different variables. So let's discuss a bit more by considering a real situation that we generally encounter in our daily life. The example is for a mass of biscuits which has 6 kg mass and it costs $27. So we are asked to calculate the price of 13 kgs of biscuits. So physically we can understand that the price will increase with the magnitude or the mass of the biscuits. So there is a direct relationship or direct proportionality between the mass and the price. So in order to solve this problem, we consider two methods. The first method is known as unitary method. In this case, we set the given data, which is 6 kg of biscuits costing, or it has cost of $27. Now we want to calculate the price for 13 kg biscuits, and in order to do that we would first want to make the or to get the cost of 1 kg of biscuits. This can be obtained by dividing 6 on both sides, that means by the mass as well as cost, which is the basics of the unitary method. So we divide 6 by 6 kg and $27. So it gives us 1 kg of biscuit cost 27 by $6. So in order to get the cost of 13 kg of biscuit, we divide In fact, we have to multiply 1 kg by 13 to obtain 13 kg. So we have to do the same with the cost. So we multiply 27 by $6 by 13. So it gives us the cost of 13 kg of biscuits equal to $58.5. This problem can also be solved by the second method, which is proportion method that we developed by analyzing the table in our analysis. You see that we have the analysis that gave us that we can use the two variables in their ratio and we can equate them. Like you see, x1 over y1 is equal to x2 over y2. So we have two variables here. One is the mass, that is in kg, and the cost, that is in dollars. So what we want to obtain or calculate is the cost. So we set the cost equal to x dollars, which we want to calculate for 13 kg of biscuits. So x1 can be set equal to x dollars and y1 is the mass of 13 kg. And we have x2 and y2 as $27, which is the cost of 6 kg of biscuits. So we have an equation which is x over 13 equal to 27 over 6 by that proportion method. Now we can easily obtain x by multiplying 13 on both sides of the equation. So this will give us the same answer that we obtained using unitary method, and it gives us $58.5. Now we can also do the same proportion method by just changing the order or variable ratio. Previously we used two different variables, the ratio of two different variables, and equated them, but we can also see that the same variable has the same or constant ratio. Like in this case, we have the ratio of the price or the cost equal to the ratio of the masses. So we use x1 over x2 equal to y1 over y2, rather using x1 over y1 equal to x2 over y2 as done above. Now if we use this method, we will have slightly different equation, but in this case we will have to multiply 27 on both sides to obtain the value of x, which is again equal to $58.5. So the cost of 13 kg of biscuits is $58.5, which can be obtained by using two different methods. Now let's see another practice problem. In this case we have the magnitude of mass of sweets, which is 50 gram, and it cost $2.1. We have to calculate the cost of 380 grams of sweet, and further we should present our answer up to the 5 cent, which means that it should be at the second decimal place in the form of or with respect to dollars. So if we want to convert the 5 cent into dollars, it will be equal to $0.05. That means we have to give our answer up to the second decimal place. So we have the same unitary method, and we see that the given information is 50 gram of sweet cost $2.10. Now dividing by 50, we get 1 gram price, which is $2.10 divided by 50. And then in order to obtain for 380 gram of sweets, we have to multiply this on both sides, which is mass and the price. So this gives us the price of 380 gram of sweets, $15.96. We have given the price until the second decimal place, as we were asked to give up to 5 cents. The second part of the problem is that we have the price of 3/4 of a metal in fact, it is the mass of 3/4 piece of metal equal to 15 kg, and we are asked to give the mass of 2/5 of the piece of metal. So physically we can understand, if we increase the size of the metal piece, it will definitely increase its mass. And that's why we can say that it is a problem of direct proportionality. Now we have the same unitary method, which is 3/4 of the metal piece equal to 15 kg mass. We convert it into one metal piece, so we get the mass of that length or size of the metal piece. Now we have to multiply with 2/5 of the metal piece to get the mass of 2/5 of the metal piece, which becomes 8 kg.